for a world that works.
Stanford University.
Climate change is no longer theoretical. It's here. Atmospheric CO2 is 40% higher than in pre-industrial times. Heat waves are more intense. Droughts are more severe. Wildfire risk is up. Sea levels are rising. Heavier rains are causing devastating floods. Infectious diseases are spreading as mosquito habitat zones expand. Economic inequality is growing. By 2050, Earth's population will reach perhaps 9 billion, requiring even more energy and food without the greenhouse gases. At Stanford, we are looking at solutions from every angle. I'm a climate scientist.
I'm an environmental lawyer.
I'm an earth scientist.
I am a biologist.
I'm a glaciologist.
I'm an energy scientist.
I'm a behavioral decision scientist.
I'm an atmospheric scientist.
I'm an earth scientist.
I'm a geophysicist.
I'm an ecologist.
I'm a climate scientist.
I work at the intersection of environmental engineering and infrastructure planning.
In order to understand climate change, we need to understand the full Earth system.
Sea level rise is having consequences for people who live on the coast. Putting careful numbers around how much the ice sheets will contribute to that is a critical component in creating thoughtful, informed policy and adaptation measures.
If we were able to say, in the next 10-year period, we're going to have 5 or 7 or 8 winters that are going to be anomalously bad compared with the normal. Now, that would be tremendously useful.
What we've experienced in California over the last couple of years is that climate damages are now. Scores are killed, tens of thousands of homes burned down. There is enormous investment in trying to improve the modeling approaches to wildfire risk, to understand what is the risk at your house.
These types of events, like extreme weather events, tend to help people make that link between climate change and their lives.
Climate change is really a side effect of something that benefits humanity. We need access to energy resources, and the combustion of fossil fuels release greenhouse gases to the atmosphere.
We can't solve the climate problem without solving the energy problem. We recognize that having a reliable, low-cost electricity system is absolutely crucial. We're at the forefront of technologies in batteries, in solar and wind and geothermal and hydropower, carbon capture and storage, natural gas as a transition fuel. At the end of the day, we can develop all the technologies that we want, but what's really going to make a difference is whether we implement them.
The entire world could lose 20% of GDP this century if we fail to do anything about climate change.
We can put a price tag on services provided by nature. The Natural Capital Project is playing a major role in the transformation underway in China. We're helping to develop a suite of new technology that will transform the way investments are made in nature. And these software tools are being used by 185 countries.
So in Costa Rica, we're partnered with some of the government agencies that are really interested in learning how we can apply these ecological concepts to improve policy around both land management and human disease risk.
A couple of colleagues and myself have started a company that's serving data to the needs of the developing world to really push forward whether we're able to feed the populations with the existing land that we have.
My group works with local governments in countries like Haiti and Mozambique and Bangladesh to engineer water and sanitation solutions that really fit.
We are working with San Mateo County to understand socioeconomic impacts of sea level rise. We are also working with San Jose to better understand compound risk from flooding.
So we have a new administration in Sacramento. We're trying to help them think through how can you move towards 100% renewable power.
Some of our emissions work has ended up in state laws and federal laws.
I've had the opportunity to testify before Congress about building a climate resilient America.
We're already finding solutions today. What we need even more of is leadership, consensus, investment, and something that's already happening, excitement and energy from a new generation.
Stanford has really done a phenomenal job of laying the foundations to now meet one of the most critical existential threats of the 21st century, and that is meeting climate change. We have to drive solutions at scale by advancing fundamental science, technology, and future partnerships. We're ready, we have the foundation, and now we need to launch into the future.
Please welcome to the stage President of Stanford University, Marc Tessier-Levine.
Well, good afternoon and welcome to all of you. Thank you all for being here this afternoon, especially on such a beautiful Sunday afternoon. I want to thank you for your interest. I want to thank you for the commitment that you're showing by coming here today to tackling some of the great issues of our day, how to create a sustainable future for our planet, and in particular, how to accelerate solutions for climate. I think we all appreciate that we're at a critical juncture today, that we have the opportunity to change the trajectory that we're on, to create a different future for our planet, and to create a better and more sustainable world. But it will require action on our part. It will require action urgently. In the next few minutes, I'd like to just share a few thoughts, first about the urgency of the challenge that's facing us, then the reasons why I am guardedly optimistic that we can make a big difference in the trajectory that we're going on. And part of that is, of course, because of the work that's being done here at Stanford by our experts who are helping lead the way, some of whom you'll hear from this afternoon. Now, the video highlighted many of the urgent issues that are facing us today and have reminded us that we're at a defining moment in human history. The first predictions of global warming came almost 50 years ago. It's a sobering thought, and it's even more sobering to think that those predictions were eerily accurate about where we are today and the trajectory that we're on today. I think it's become increasingly apparent that the nature of the threat is incredibly serious. This has been hammered home by many events over the past decades, over the past years, over the past months. This summer has been a summer of extremes of temperature, extremes of climate events. And there's greater recognition of the importance of this. The UN Climate Solutions, our summit, just occurred a few weeks ago in New York. Perhaps more poignantly, the youth strikes that have occurred all across the world have shown that the young people of the world are rising and adding their voices and their sense of urgency to the issue as well. Now, each of us, I think, feels this at a very personal level. For me, this was really captured very movingly by a healthcare worker who was cited in the Washington Post. And this person said, "I'm deathly afraid, not for my kids, but for my kids' kids and what they will have to deal with. What are we leaving as a legacy besides a hot mess?" Now, the commitment that I see in this room by all of you who have come here today, by our faculty, by our students, shows to me that we all believe that our legacy does not have to be a hot mess, but we know that we have to tackle the problem today and that we cannot delay. Now, I am guardedly optimistic about the future, and that is, of course, grounded in my appreciation of the work that's happening here at Stanford, as well as at many other institutions around the world. Institutions like Stanford can bring people together, can help catalyze new ideas, can help accelerate the development of new technologies, can create new knowledge free of ideology, and also help us act quickly and nimbly, and all of that is necessary for us to get to a better place. This type of work really is part of the DNA of Stanford from its founding in 1891. The purpose of the university is to generate knowledge and applications to better the human condition. The university has actually been at the forefront of climate science since the 1970s, and especially in the last 15 years, we made huge investments in this area. Many of the early pioneers of those efforts, many of the generous partners who have supported those efforts are actually here today. So I want to thank them, all of those who are here, for all their hard work over the years and also the clear commitment that they show to continuing this fight by their presence here today. In the last 2 years as a university, we've worked collectively to define where we want to go with the university over the next 5, 10, 15 years and beyond. We've been doing this across all fields, but we've had a very big focus on sustainability. Our vision has been coming into focus. The plans are being crafted and should be finalized in the next month or two. They include a number of priorities. One focused on transforming our energy system, including the grid. The second on accelerating the development of sustainable technology solutions, for example, for carbon capture, for batteries, for many other things. Also, a focus on adaptability and resilience, and especially to protect the most vulnerable communities in our region, in our nation, around the world. and also to use economic analysis and policy formulation to try to create incentives to protect the planet and its inhabitants. In addition to our work in research, in engineering, in policy development, we believe we have an opportunity and in fact a responsibility to lead by example, taking advantage of our campus community, about 35,000 people, really a small town if you will, and to be a living laboratory for the implementation and development of sustainability solutions. Over the past several years, we've made the commitment to decarbonize our campus. From our peak less than 10 years ago, we are now 65%. We've reduced our carbon emissions by 65%. In 2 years, in 2021, we will be 80% carbon-free, and then we will drive it to completion. We've also have a focus and a commitment on waste reduction, recovering clean water and energy from wastewater, and we've made the commitment to be waste-free by 2030. As we do this, as we experiment on our campus, as we generate data and experience and new tools and implement them, we also believe it's essential that we engage and share all of our best practices with other universities, with non-governmental organizations, with corporations, with governments around the world. We have to share all of these best practices so we can accelerate the development and the implementation of sustainability solutions at the local level as well. What makes me most optimistic is the brilliance of our faculty and our students, some of whom you will see today. Their drive, their expertise, their ingenuity, their tremendous insights are extraordinary, and above all, their unrelenting commitment and their passion to tackle the problem is what inspires me every day. So, in conclusion, I want to reiterate my optimism. But of course, we know that we can't just be optimistic, we actually have to get down to work. We also have to focus on pulling all the levers. There's no single lever that we can pull to get to the solution. We have to pull all of them. No one person, no one institution, no one nation can solve this problem for all of us. We have to work collectively. This is a global problem that requires each of us to engage, but each of us to engage also with our communities and communities around the world. But I believe that Stanford is well positioned to help lead in this through bold and transformational ventures. And with your help, I think that we can go the distance. So I want to thank you again for being here. I want to thank you for being part of the solution of what is perhaps the biggest problem and gravest problem facing humanity today. Thank you very much.
The other day, I was teaching about 50 political journalists about climate change. And they were absolutely shocked to learn that we could reach the 2°C climate threshold in 30 years or less. Now, maybe 30 years sounds like a long time, but in infrastructure years, 30 years is just the blink of an eye. Think, for example, how long it took to rebuild the Bay Bridge after the 1989 earthquake. But the reality is that we have to get off the path that we've been on, where carbon dioxide emissions that cause climate change continue to rise year after year. We have to bend the curve and drive emissions down to zero sometime in the latter half of the century. Now, what I would like to do is talk with you today about why I'm optimistic that we can deal with this challenge. But first, let's step back and take a look at the source of the emissions that cause global warming. About 76% of these carbon dioxide emissions come from energy, that is, burning fossil fuels. So that's the good news, and that's the bad news. And the bad news is that fossil fuels provide very reliable and relatively low-cost energy that's really the backbone of our modern economy. So we can't afford to jeopardize that. But the good news we can see is that if we can eliminate the emissions from the energy sector, we've dealt with the lion's share of this problem. Now, 10 years ago, if you asked me whether we could reduce the energy system's emissions to zero, I would have said it's impossible. But the reality is that solar panels, wind turbines, lithium-ion batteries, the prices for these zero emissions technologies has plummeted over the last decade. And in fact, these technologies now often provide the lowest cost source of electricity we have. And because of the low cost of lithium-ion batteries, we can also now have electric cars, and we can use these same batteries to back up the electric grid when the wind's not blowing or the sun's not shining. So in fact, it should really come as no surprise that in some parts of the world, these technologies are being adopted very quickly. And in fact, there are many places where over 50% of all the electricity they use actually comes from these renewable resources. And something that I never thought that I would see in my lifetime, for the first time ever in the United States, for the entire electricity system, renewable energy generation topped coal. I never thought that I would see that in my lifetime. That's truly incredible. I agree, that's truly incredible. So then I'm sure you're saying, well, why can't we go farther? And why can't we go faster? And why isn't everybody doing this? Well, the electricity system was built when we had coal plants and gas plants. And you can turn them on when you want, and you can turn them off when you want, and you can control how much power they put out. But we can't control the wind, and we can't control the sun. So integrating these new technologies into the grid is like putting together a puzzle. All the pieces have to fit together in the right way. We need to figure out ways where we can figure out what is the right combination of wind resources and solar resources and battery electric storage. And how do we charge the tens of millions of electric vehicles that we're going to have? We need to figure out how to put the pieces of the puzzle together. And this, I'll tell you, is the forefront of innovation in energy technology today. And Stanford faculty are leaders in all of these areas and can bring their tremendous talents together to address these issues. I can tell you, here in Silicon Valley, you're sitting in the epicenter of energy innovation here at Stanford and the Valley. There are over 1,700 energy-related companies in the Bay Area today. Who would have thought that just a decade ago? So grid operators are going to need much more data than they've had in the past to operate the grid reliably. And we're going to need to analyze this data in real time so we can optimize how all these pieces fit together. And we're going to need to send control signals to tens of millions of devices on the grid so that we can make this system work. This is the frontier of energy innovation. Due to the urgency of climate change and due to the availability of these low-cost solutions, many nations, states, counties, cities, corporations, and universities like Stanford are developing their own ambitious climate goals. And in fact, many have committed to 100% zero-emission energy system. But they'll be the first ones to tell you they don't know how to get there. And that's where Stanford can help. We're working together with our partners to identify solutions that they can implement today and continue to implement further into the future so they too can get to zero emissions. A really good example is our work with the state of California. California has committed to 100% clean electricity by 2045. So we're using our models and computational algorithms to figure out what's the best combination of renewable generation, battery storage, combined with traditional generation to drive towards zero emissions, but at the lowest possible cost. And this is important because transitioning to zero emissions has to be affordable. Driving towards zero emissions, though, is not a linear process. It's a cycle. So just like diet and exercise are vital for human health, implementation and innovation are vital for the health of our planet. We call this platform of innovation and implementation Zero Emissions Energy Solutions. Now that's quite a mouthful, so I just like to call it Z's. And one of the best things about Z's is that the solutions we create together with our partners are made available through an open source toolkit so that everyone around the world can benefit from the solutions we develop. I'd like to switch now to thinking about the future, thinking about innovation in the future, and what the next 10 to 20 years looks like to us. I'm going to give you 4 examples. The first example will be about batteries. Stanford faculty are working on batteries that can store twice as much energy. So what does that mean? You can drive twice as far in your car, but maybe even more important, we'll be able to start to electrify heavy-duty trucking. And what about hydrogen? Hydrogen is the cleanest fuel. When you burn it, the only thing that comes out of your tailpipe is water. But making hydrogen from renewable energy today is just too expensive. So Stanford faculty are developing new materials and new processes so that we can make low-cost hydrogen from renewable energy. And what I show here is a sector that is often overlooked when we think about zero emissions, and that is the industrial sector. About 25% of carbon dioxide emissions come from the industrial sector, so we have to deal with this too. Iron and steel, cement, chemicals, aluminum. These are the materials of our modern economy. And today, we make them with fossil fuels. And unfortunately, we don't have a good substitute yet. So this is where carbon dioxide capture and storage comes in. We can capture the carbon dioxide from the smokestack before it ever gets into the atmosphere. We can purify it, and we can put it back underground where it came from in the first place. And Stanford faculties are leaders in making sure that this can be done safely and effectively. And I'll give you just one more example. So imagine one day that we would be able to make liquid fuels like gasoline and diesel from renewable energy. Well, our faculty are working taking carbon dioxide from the air, combining that with water, and making those exact same fuels that our economy relies on today. That would be a game changer. So I can tell you, we can actually do this in our laboratories today, but it's too expensive, way too expensive, and it's not very efficient. So discouraging maybe, but what I want you to do is to think back to the 1970s when we first started manufacturing solar panels. They were way too expensive and they weren't very efficient. But look at what a couple of decades of innovation has done. Solar energy is now some of the lowest cost energy in the world today. This is why I'm hopeful. Climate change is a complicated issue requiring multifaceted solutions. Yes, we need renewable energy, and yes, we need better batteries, and yes, we need electric cars, and yes, we need carbon dioxide capture and storage. And yes, we need to accelerate implementation of those technologies that are cost-effective today. And yes, we need to continue to innovate because we still have lots of work to do. We need it all. That's what zero emissions energy solutions are all about. And we here at Stanford are committed to ensuring that the innovations in our laboratories are implemented in the real world, and that what we learn with our partners fuels the next cycle of innovation. Thank you.